So just a revision of what an operating system is. It's a piece of software that basically runs your computer. It's simple as that. And it manages your applications, it manages the hardware and things, all these sort of things. Another thing it does do, which we'll talk about later, is it also manages storage. We'll talk about that as well. But essentially, all you have to know about an operating system, it runs your computer. Effectively everything from a guided missile to your router to your phone runs an operating system of some kind. Now, the one we're going to talk about today primarily is going to be about Linux or Unix, because that's the main operating system we use for IT for most of your development work. So there's other types of operating systems out there. Obviously, there's Windows-based operating systems. Windows 10 has just been released, woohoo. That's actually called Windows NT. Under the covers, the operating system is actually called Windows NT, strangely enough. And for example, Windows 7 is Windows NT 6.1 under the covers. So what you're seeing at the front end is a whole bunch of nice stuff on top, GUI, graphical user interface, drag, drop, touchscreens, whatever. But under the covers, the kernel is still based on an original kernel designed sometime in 1999. So we've incrementally changed it 6 versions later, but still it's the same operating system under the covers. And of course, there's the mobile phone operating system. Symbian's one of the yuckiest survivors out there for Nokia phones. Poor Nokia, may the rest in peace. I think Microsoft dumped them, didn't they? So that's a really old one, but it's an example of an embedded operating system because it's made for really, really low-end CPUs, extremely low-end. You'd say we've got 16K of memory or something like that. It's really exciting stuff. Our watches are better than that. So I'm going to talk a bit about Unix, but very, very briefly. So I will skip some slides very quickly. First of all, what's Unix? Well, obviously where it's used is fairly obvious. We're using it in our classes, simple as that. We use it everywhere from, there'll be a system called Rerun, which you'll get to play with eventually. It's a system that you can connect in from home to our workstations. So we can show you how to get access to that later, but all IT students have access to that. It's used everywhere, like you've got Mac OS, it's called a BSD, or Darwin, it's what it's actually called under the covers. All these other phones out there as well. Let's take a look. Hang on. Why is this page not flipping forward? A little system problem here. What's going on? Okay. So I keep talking about Macs. I keep talking about Linux. There's really 2 sources of Unix out there. A long time ago, in the good old days, a company called AT&T created an operating system. AT&T is a telephone company. It's like a giant Telstra in the US. And this is in the 70s, a long time ago. Cute little star there for Linux. One of the reasons Linux came out quite well is because it's open source and it's free. So instead of having one single team developing Linux and Unix in general, you had literally thousands or tens of thousands of developers out there. So Linux is quite good in a sense that you had millions of eyes looking at the operating system, and Linux is extremely reliable. To give you an example, Linux Gem, that's the operating system that we're running. It's actually a server running a thing called Debian. It's actually been running continuously for about, well, we rebooted last semester, but before that, it was literally running for 4 years without a reboot. You can't really do that with Windows. So it's quite an interesting system. And because it's totally and utterly open source, a lot of people modify it directly. Now, quick question. I think last week we asked who ran Linux. We had a few hands up. What distributions did you guys run? Linux guys, apart from Android. Sorry? Yes. Does anybody run Mint? Ubuntu? Yeah, Debian? Yeah, a few of you. Anybody run Red Hat or CentOS? Red Hat, yeah. The Unix that you're running at the workstations are called Red Hat Enterprise Linux. So if you have a chance to do a Google, look at the word distro watch, DISTROWATCH, and you'll get to see what the top distributions of Unix are at the moment. Rough guess on that one. One of the big problems is that because it was so open source, people did everything with Unix. A group called IEEE, this big standards organization, they developed the Wi-Fi standard, they developed Ethernet, etc. They standardized it. They tried to standardize Linux and Unix in general. When you have a committee, what happens? You get a camel, don't you? Something like that. The camels are quite good, actually. I don't know what they say. It's bad. So they tried to make a standard, and quite frankly, it was a disaster. Basically, design by committee doesn't work in the world, and what happens is you end up with a system which nobody adopted. So forget it. Everybody said, this is crap. So what happened is everybody just ignored it, and you had hundreds of different types of distributions out there. And it still happens now. You go to Red Hat, it's different from Debian and so on. You go to AIX, you have no idea what the configuration files are. What finally happened in 2002, the whole bunch of vendors, right? This is not standard organizations got together, and they created a thing called SUS, the single Unix specification. And they simply agreed on it. Problem is, the word Unix itself. I keep saying Linux and Unix interchangeably. It's not. Technically, Unix is the generic name. Linux is a product. Keep that in mind. Okay. So they defined that Linux was actually Unix-like, so I didn't have to worry about copyright. There's a few other operating systems out there, by the way, apart from Linux, apart from Windows either. The ancient one, IBM. IBM has been around for a lot longer than Linux and Unix. So many different operating systems come and go. You're going to look up Wikipedia, look at the word operating system. They've got a humongous list of all these obscure ancient operating systems. And they all died. There really is, quite frankly, only one main operating system in the world that survived. And that's Unix. And it simply survived because of that open source, the open design. And one of the really, really big, powerful concepts they did was that you can do anything you like. And they said everything is really small. So when you do the labs today, you're going to execute tiny little commands. And really, Unix is made from a whole bunch of tiny little commands joined together. And that's all it is. It's a simple concept. The big concept for me is that anybody can do their own thing with Linux. You can write your own distribution if you wish. You can modify the kernel if you wish. You can write your own obscure commands if you wish. The problem is, who will use it? Like, it's a real pain. Nobody will use it. They'll use the Wongian or something like that. So if you really want to do something silly, make your own distribution and look up distro watch if you have a chance. I'm going to fire up the window on this one. And you'll see that there's millions out there, but some of them hardly are used by anybody. Look at that in a moment. I'll just fire it up to a search for it first. Okay. Right. The other concept that you're going to find really interesting in Linux, or Unix if you can, is they decided everything in Unix is either going to be a file of some kind. It's either going to be a character file or a block file. That's it. Even the hardware is abstracted to a file, and even the operating system itself. So I'm not going to show you the example of that, but even things like, for example, your mouse is actually considered a special file. So you can write code that works with different types of things when you don't have to change it dramatically. Very, very simple things to do. When Linux was designed, or Unix was designed, the concept of a mouse didn't exist. Yet Unix is perfectly happy with it. They simply added a device called dev mouse, and you can use it. And it doesn't matter if it's... Anybody heard of a serial mouse? A few of you, yeah. Everything's USB nowadays, but USB only came out in the 90s. So even then, they wrote the device drivers to do that. But it all was the same piece of code. You didn't care what it was. That's one of the best things about it. And the other thing about Unix is they wrote it in a high-level language. Well, it depends on your point of view, called C. Now, guess what? Most operating systems before then were written in a thing called assembler. And we're not going to talk about assembler. It's incredibly painful to write. I used to write assembler. I used to be a system engineer. I used to write device drivers. So it's the most painful thing on the planet. C was a big order of magnitude easier. You could actually write a code that made sense in English to a certain extent. You put comments in it, basically. So you can write a compiler in any thing. For example, this phone runs a CPU called ARM. But Linux was originally written for a thing called the PDP-11. So continually, they can recompile the C compiler and then recompile Linux or Unix to a new CPU. So you can make your own CPUs and write a copy of Unix for it. No problems there. Very simple. Conceptually, it's the same piece of code. Skip through this. Don't need that fast and stable. At UTS, we're going to use 2 versions of Unix. Okay? 99% of your time is going to be based on a thing called Linux. But there's another operating system which you will get to use a bit later on. If you do programming, who's doing enterprise system development? Yeah, when you guys start doing a thing called application programming, you'll have to use a thing called rerun. It's a Solaris system. You'll get to play with that a bit. What you're going to do is you're going to do a lot of training in Linux Gym on this. This is all I'm going to talk about Unix. It's really just a basic introduction to it. You can learn a lot more if you want to. We've got 2 more subjects that really delve deeply into Linux if you're interested. It's called Network Servers, which I'm teaching this semester. And there's another one called, it's part of network security. I think you get to play with the operating system at a low level. So that's another subject where you really delve into Linux deeply. Otherwise, you can forget it. Let's take a quick look at DistroWatch and see what we've got. Okay, I think we had a good... So this is a website where you want to see what copy of Linux is the most popular. On the bottom right-hand side, which is based on Red Hat. So the most popular Unix distribution out there is called Mint. And the second most popular and that's an operating system which is, I've used it since version 2. I've loved Fedora since I was young. But it's all basically very popular with corporates. A lot of corporates use a thing called Red Hat. Notice it's 41 because you have to pay for it. If you have to pay for it, of course, it's not that popular. CentOS is the open source version of it. But CentOS is exactly the same as Red Hat. Interesting that you don't have to pay for it, though. That's a few examples. Notice Android x86 at number 12. Google the word Andy, A-N-D-Y-O-S. You'll actually find that's a version of, it's a virtual machine that runs Android. So you can actually run your games on your Windows 8 operating system. It's pretty cool. I used to play Minecraft. Not that I play much games. Okay. So I'm not going to ask for a vote on who has the best because last time we saw only about 20% of this class actually have used Unix before. Okay, so that's Unix. What I want to talk about next is the more interesting point. We talked about operating system. And so what does the operating system do? Remember I said the operating system runs, it's basically the program that runs your computer. So things an operating system has to do include things at the bottom, manages hardware, and it manages programs at the top, user programs. Simple as that. You run a program, PowerPoint. But the other big thing it does, which is really important for all of this, is it runs storage. Like, without storing my files somewhere, it's pretty useless, isn't it? We all do cloud storage nowadays, but still it's stored somewhere. Cover what an operating system does at that level. Now, file system. Who knows what a file system is? Anybody can name a file system? Sorry? I've heard the word NTFS. I just realised I forgot to put my hearing aids on. I can't hear you guys. Okay, somebody mentioned FAT, somebody mentioned NTFS. Who's got a rough clue of what, say, Macs run? Sorry? mathematician or something like that. Yeah. A common one on Macs is called HFS. But we don't really care about the Mac, do we? Yes, we do. It's one of the most popular ones for Mac is called HFS. It's a very common one as well. There's a new one coming out from Microsoft called exFAT. It's a new one as well. So if you get a lot of USB hard disks, it's got exFAT on it, which incidentally doesn't work on our machines at university. Okay, so that's a file system. So a file system does things like store files. Is that a stupid question? A tautological thing? But typically, a file system's got to be stored somewhere. Now, who's heard of a physical hard disk? I mean, it's starting to get obscure nowadays. Anybody heard of a hard disk? A hard disk, and I'll show you a physical example in a second. Oh. And it's simply these portable hard disk here. Anybody have one? You just hold it up. Oh, you're not going to do it. Okay. I'm not going to show you this because I'm actually running a flash drive in this. It's a bit of a cheat. But original hard disks look like this. Since time immemorial, I'm talking about before we were born, 1960, was run on something like this. Hard disk, physically plain, electric motor inside. They run at certain speeds. Modern speeds, they run around 5,200 RPM. That's rotations a minute, so I can't even get vaguely that fast. And they've got things called surfaces. This surface is magnetic, so you can play with it. It's magnetic. And they have little tiny tracks on them. You can't see it because it's magnetic, so I drew it. You see the line there? I drew a little track, and there's literally thousands of it on this disk. What happens is this little thing called a head. This thing here moves forwards, backwards like this, and it reads the track. So it reads like this. I'm going to read a block. This is a funny black block. Reads the dark. Reads the dark inside. Because there's hundreds of it, it moves back and forth. Right here at the end, when you pass this around, you can take a look. That's what I hear. It reads that track. It sends data to the wire here. Wire. Down here, it goes out to the interface of the computer. Imagine this in a laptop. Now, obviously, one single platter might hold a lot. Guess how much this disk stores? Let's have a bit of a poll. This is a 5 terabyte drive, right? Sorry? 20 kilobytes? Megabytes. This side has a magnetic surface. So when this head moves back and forth, it's actually, I don't know if I can show you this side here. Hopefully you can see it. Piece of metal here. Take a look. Okay, so it moves back and forth. And that's how basically how a hard disk works. Let's take a look at it again. Right, so what have we got here? Oh. Come on, what's happening here? This one doesn't like bringing out the USB, the HDMI. Oh,